Okay, so on the review, first off, it starts with just reducing radicals. We've done this quite a bit. You can use the birthday cake method, or you can just look for the biggest perfect square. On this first one, the biggest perfect square that goes into it is going to be 4. So when this splits into 4 and 6, square root of 4 is 2, that's 2 square root of 6. On the second one, we have 75. That's going to split into 3 and 25. The square root of 25 is 5. That's 5 square root of 3. Make sure that you're not like getting stuck on this. Make sure that you're not reversing them. If you want to use the calculator is capable of finding the decimal equivalent here. And 3 square root of 5 is not going to be the same thing as 5 square root of 3 that the correct answer is supposed to be on number 2. Is what? Yeah, 3 and 25. Aside from that, the decimal equivalent thing, remember, like, it will still say that it's the same thing, even if the answer hasn't been reduced. So aside from just decimal equivalency, you do want to look for whichever answer has been reduced the most. Don't get fooled by number 3, that's cube root of 16. The square root of 16 would just be 4. But if you do the birthday cake method on this one with 16, that's 2 and 8, that's 2 and 4, that's 2 and 2, that's 2 and 1. We have 3 2's, and then we have a 2 left over. So this is going to be 2 times the cube root of 2. You have to be very careful when it's cube roots, fourth roots, fifth roots, to make sure you look for a group of that many. Yeah. Well, if we'd have done this one birthday cake method on number 2, that 25 would have split into 2 different 5s. So the 5s would have been grouped together. They would have gone to the outside. This 3 would remain unpaired.
Oh, because there's 2 5s.
Right.
Okay.
On number 4, that's a negative sign outside, which means it will stay a negative no matter what happens. So we've got 48 divided by 2 is 24, divided by 2 is 12, divided by 2 is 6, divided by 2 is 3, divided by 3 is 1. Since this is fourth root, we're looking for a group of 4. There are 4 2's, which is going to make a single 2 on the outside. So that's a negative 2 times the fourth root of the 3 that we had unpaired. All right? I do want to get to, I'm going to skip number 5, but I am going to go to number 6. On the 64 is not a perfect fourth. Okay? When we start to reduce it, we are looking for groups of 2. 64 divided by 2 is 32, divided by 2 is 16, divided by 2 is 8, divided by 2 is 4, divided by 2 is 2, divided by 2 is 1. So as I reduce that, a group of 4 is right here. That's a single 2 on the outside. There are 2 unpaired or ungrouped 2's. I'm going to multiply those back together, and they are going to stay underneath. So it'll be fourth root of 4 with a 2 on the outside. Whenever you have variables on the inside, you're going to have that exponent, and you're going to divide the exponent by the index. So in the case of both of these, that's a 4 divided by a 4, which is 1. That's a single A. A 4 divided by a 4, which is 1. That's a single B. Both of those on the outside. Cube root on this next one, if it's a negative, you can do the cube root on the inside, and you can do cube roots with negatives. So this will be a negative 2. Again, I go to like divide out. Then it's negative 2 because it's to the third power. Like negative 2 times negative 2 would be a positive 4 times negative 2 would end up being a negative 8. So it's a perfect cube. And because it's negative, we go with negative. You have to be very careful on that. Again, this is something that you can type in on the calculator. if you do control and then the power button, the raise to, the little carrot, rooftop, whatever you want to call it, when you put that together, you can do the cube root. You just have to type a 3 in there. The d squared, nothing's going to come outside because we're looking for groups of 3, and that's 2. The f, though, there's 5 of them. 3 is going to go into 5 one time. So we're going to have an f on the outside. We have 2 left over. So still under my cube root is d squared and f squared. That f that moves to the outside takes care of 3 of them. So that's 1, 2, 3, 4, 5 f's. So all of them are there. All of them are accounted for. Be careful on ones like number 8. This r squared and this t are actually on the top of the fraction line. Don't let the fact that they're written out to the side mess with you. Square root of 25 is 5. Square root of r squared is r. The square root of t is the square root of t. And then the square root of 36 is 6. That one's just going to reduce like that. On the next one, square root of 3 over 7, that fraction doesn't reduce. So it's the square root of 3 over the square root of 7, and it's negative. We multiply by the square root of 7 because that would get rid of our radical that's on the bottom of the fraction here. We end up with a negative square root of 21 because outside times outside, inside times inside, over 7. Okay? We would have the square root of 49, and that square root of 49 would reduce to 7. Okay, gonna skip over a couple real quick. On number 12 here, when we're multiplying like this, you don't need the boxes, okay? It's just outside times outside, inside times inside. So 3 times 5 is gonna be 15. 3 times 3 is gonna be 9. The square root of 9 I can reduce. That's just gonna be 3 times 15, which gives me 45. Same thing with number 13. The square root of 9 is 3. So I multiplied that by 15, and that gives me 45. On number 14, we're just adding. We can only add the like terms, but these can reduce. So the square root of 2, 8 is going to reduce down to 2 square root of 2. And 50 is going to reduce to 5 square root of 2. So when I go to add all of those together, that's 1 plus 2 is 3, plus 5 is 8. So that's 8 square root of 2. Okay? Similar kind of thing here on 15. 12 is going to be 4 and 3, so that's 2 square root of 3. And then minus 2 square root of 3. 108, I'm not real sure. Let's go ahead and birthday cake that one out. That's going to be 2 and 54, which is going to be 2 and 27, which is 3 and 9, which is 3 and 3. So I've got a pair of 2s, I've got a pair of 3s. That's going to be plus 6 square root of 3. 2 minus 2 is 0, plus 6 is 6. So it just stays 6 square root of 3. Okay, again, you can check for equivalency. You can type these in. You can find a decimal answer there. So it shouldn't provide you with too much of a challenge. Let's skip down a little bit. Let's take a look at number 18. Number 18, we have unlike terms in the parentheses. I can't just multiply outside by outside, inside by inside. I'm going to end up doing the boxes. So that's 2 plus the square root of 3 times 6 minus the square root of 2. That's 12 plus 6 square root of 3 minus 2 square root of 2 minus the square root of 6. Normally at this point, I would have some like terms. In the case of this one, I don't. I don't at all. So this is the whole thing just written out. It's 12 plus 6 square root of 3 minus 2 square root of 2 and then minus the square root of 6. Nothing else I can really do there. If you get ones like number 19, those are conjugates. It's the exact same numbers. The only difference is the sign. So this you can work a lot faster just by squaring each part and then subtracting. So 1 squared is just going to be 1. The square root of 5 squared is just going to be 5. I subtract, and that gives me a negative 4. If you're not real sure what you're doing on that one, you can, of course, multiply it out with the boxes, but this should be what you end up with anyway. And I think when it's one like this, when it's the conjugates, you should actually be able to put it into the calculator, multiply it out on the calculator, and it'll still tell you that this is the right answer. On number 21, keep in mind when it looks like this, that means you're going to do the boxes. And it's going to be the same thing on both sides of the boxes. Square root of 2 minus square root of 6. Square root of 2 minus square root of 6. Square root of 2 times square root of 2 is the square root of 4, which is 2. This is going to be minus the square root of 6 times 2 is 12. 6 times 2 is 12 here too, so that's minus the square root of 12. And then 6 times 6 is going to give us the square root of 36, which is 6. And a negative times a negative is going to give us a positive 6. So I combine like terms. 6 plus 2 is 8. Negative square root of 12 and negative square root of 12 is minus 2 square root of 12. Normally I'd be finished. This on your test would probably be one of the multiple choice answers. And the fact that this would be one of the multiple choice answers is probably why so many of us had some trouble on the quiz. This is not the correct answer. Okay? Because we haven't finished reducing. 12, you can take a 4 out of that. So the square root of 4 is just 2. So this is going to be 8 minus 4 square root of 3. Okay? This is still under the square root, but the square root of 4 is 2. That 2 moves to the outside where we already had a 2, and 2 times 2 is 4. So this is my final answer there for number 21. 8 minus 4 square root of 3. This 22 and 23 were added on by someone who made the test and realized that the test had questions like this. If you get one like this, either number 22 or 23, it's the exact same process on both of them. You distribute. Now with the square root of 20, you can already reduce that one. So you could reduce it before you distribute, or you can reduce it after. It actually won't make a difference. I'm going to wait till after. I get the square root of 40 plus 5 square root of 20. 40 is going to be 4 and 10, so that's 2 square root of 10. Plus, on this side, that's 4 and 5, so that's 10 square root of 5. Okay? So 2 square root of 10 plus 10 square root of 5. I can't put those together. I can't work them out any further, so that's where I'm going to stop there. I'll go ahead and finish this whole thing out. I'll get it posted to the Google Classroom. I'll get some blank copies posted to the Google Classroom. If you have any other questions, make sure to stop by and ask before we take the test.